welcome to 3.5. This is an introduction to what we're going to be doing here for the next section. And we're talking about linear equations and rates of change. So in this lesson, you will continue to develop your skills with equations, graphs, and tables of data by exploring the role that the value of b plays in the equation of y equals a plus bx. Alright, so it's this equation, y equals a plus bx. So this, again, it isn't necessarily what letter we use for b, just as long as we're talking about the coefficient of x. All right. You have already studied the intercept form of linear equations in several real-world situations. You have used the intercept form to relate calories to minutes spent exercising. We've talked about floor heights to floor numbers and distances to time. So defining variables is an important part of writing equations. Depending on the context of an equation, its number takes on different real-world meanings. Can you recall how these equations modeled each scenario? Let's look at these equations. So we had y equals 215 plus 3.8x. Calories burned during a workout, right? She started at 215 and added 3.8 calories burned per minute. 321 minus 13x. Floor heights in a building. So they originally were at 321 meters, right? And went down 13 meters every floor. Right, the next one. Earnings from mowing lawns. Negative 300 plus 15x. Well, you had to spend some money, right, before you can make money. So you were in the whole 300, but you gained $15 per lawn. Well, y equals 45 plus 0.12x. Income from restaurant tabs. Well, you gained $45 no matter what. It's kind of like a base salary for working the number of hours you did, plus 12 cents per plate, or 12 cents per table, or 12 cents per hour, something like that. All right, and then y equals 220 minus 1.2x. Distance a car is from Flint. They were 220 miles away, and they were driving closer at 1.2 miles per minute. All right, so notice how they all start somewhere and how they all change by a certain number. All right, so in most linear equations, there are different output values for different input values. This happens when the coefficient of x is not 0. You'll explore how the coefficient relates input and output values in the examples and in the investigation. All right, so now we're going to start talking about input and output values. In addition to giving the actual temperature, weather reports often indicate the temperature you feel as a result of the wind chill factor. This wind makes it feel colder than it actually is. In the next example, you will use recursive routines to answer some questions about wind chill. All right, so before we do that, let's go on and do this example A. All right, so example A, the table relates an approximate wind chills for different actual temperatures when the wind speed is 15 miles per hour. Assume the wind chill is a linear relationship for temperatures between -5 and 35 degrees, and we're going to talk about this as in Fahrenheit, okay? So part A, what are the input and output variables? Well, the input is going to be the temperature. The output is going to be the wind chill, right? If we input a temperature, we're going to get a wind chill out. If I input a wind chill, it's kind of weird to get just a temperature out, right? It's kind of a backwards way of looking at it. So the input is going to be the temp, all right? And the output is going to be wind chill. All right. What is the change in temperature from one table entry to the next? And what is the corresponding change in the wind chill? So if we're going here, we're going up by 5s, which is kind of different. We've been going up by 1s or maybe by something else, but now all of these are going up by 5s, right? 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35. Okay, so all those are going up by 10. And how much are these going up? Well, you could look at these. I could also look at any two, and hopefully it's going to be the same, right? 19 to 25.4. Well, 19 to 20 is going to be 1 plus 25 plus 5.4. So I should get a change in the wind chill of 6.4. And let's see if that's right. From here to here plus 6.4, I'll end up with negative 19.4. So that's good. So we have 6.4 for the wind chill, and the temperature changes by 5. All right, so then part C, use calculator list to write a recursive routine that generates the table values, and let's find the missing entries. All right, so let's go to the graphing calculator. All right, so here is the calculator. What I've done is I've already put in the initial numbers, right? -5 is for my temperature, and -25.8 is for the wind chill. Notice how neither of these numbers are 0, but that's still okay because I can still enter these into my graphing calculator. Okay, so now what we're going to do is we're going to open this up again, and we're going to say answer 1. And then what are we doing with those temperatures? We're adding 5, right? And then answer 2. And what are we doing with answer 2? Well, if you remember, we're adding 6.4. Okay, so we're going to add 6.4. 4. Alright, then I can close my bracket. And then let's see if I get the right number. Negative 19.4 when it's at 0. That's what I got here. That's a good sign that I'm probably doing this right. So if I enter again, I get 5, negative 13. Yes, good. And now the next one I'm going to fill in. So it should be 10, negative 6.6. So I get right here, negative 6.6. If I go to 15, oops, I don't want that. I wanted this. So if I hit enter again, I'm going to get 15 and negative 0.2. So we get negative 0.2. And then I have 20 is 6.2. Still on pace. Good. 25. I should get 12.6. And now I've filled out the table. So there we go. And we are done.